Welcome back to the Professor Insight podcast, where we unpack the complex world of artificial intelligence, neuroscience, and emerging technology, and make it practical for business, research, and everyday thinking. I'm your host, Billy, a professor of consumer psychology and neuroscience. As always, we would like to acknowledge that this podcast is fully powered by AI tools, from content creation and script writing to voice generation. In fact, this voice you are hearing is a voice clone of myself. This is all done with human supervision and manual curation. Today, we're diving into part 2 of our special two-part series on one of the most powerful skills in the AI era, prompt engineering. It is important to note that this special two-part series is based on the prompt engineering resource authored by Lee Boonstra at Google. If you missed part 1, we laid the foundations: how large language models work, how they predict tokens, and how basic prompt structure and configuration settings like temperature and output length can dramatically shape your results. Today, we're leveling up. In this episode, we're going beyond the basics into advanced prompting strategies, the kind that allow you to get not just better outputs, but smarter, more strategic, and even more creative ones. First up, we'll explore chain of thought prompting, a powerful technique that helps models reason step by step before giving you an answer. It is simple to implement, but has a big impact on how the model processes complex tasks. We'll then shift gears into more technical territory, exploring advanced prompting strategies that go beyond what most non-technical users of large language models and generative AI typically encounter. We will start with self-consistency, a technique that enhances accuracy by generating multiple reasoning paths and selecting the most consistent answer. Think of it as asking the model the same question several different ways and choosing the best result. Then, we'll take it a step further with tree of thought prompting, a method that allows the model to explore multiple lines of reasoning at once, much like navigating a branching decision tree. It's ideal for tackling complex problems that require exploration and comparison. From there, we dive into react prompting, where the model doesn't just think, it acts. This is where agentic AI comes in, something we have talked about in this podcast. It reasons, performs an action using external tools, observes the result, and adjusts its approach. After that, we'll bring things back down to non-technical realm with more accessible and practical techniques for general users. We'll look at automatic prompt engineering, where AI helps improve its own prompts, and code prompting, which can assist with writing, explaining, translating, and debugging code, even if you're not a developer. We'll wrap things up with a summary of key best practices, including how to structure prompts clearly and provide useful examples. Whether you're just starting out or looking to sharpen your AI skills, this episode will give you the tools and insights to prompt more effectively and creatively. Whether you're experimenting with AI and even building with AI, managing teams that use it, or just want to get better results in your daily workflows, this episode will give you the strategies to push your AI prompting skills to the next level. Let's get into it.
Now, chain of thought, COT prompting, sounds like it's about getting the AI to show its reasoning process, like showing your work in math class.
Exactly. Chain of thought prompting is a powerful technique specifically designed to improve the reasoning capabilities of LLMs, particularly for complex tasks that require multi-step inference or logic. The core idea is to explicitly prompt the model to verbalize its intermediate reasoning steps before arriving at the final answer.
Making it think out loud.
Pretty much. You essentially encourage it to think step by step. This process helps the model break down complex problems into smaller, more manageable pieces, making it easier to arrive at a correct and well-supported solution.
What are the benefits?
Well, the beauty of COT is that it's a relatively low-effort technique. Often just adding, let's think step by step, to your prompt can work wonders. It can be remarkably effective with many readily available off-the-shelf LLMs without requiring any specialized fine-tuning.
So easy to implement.
Yeah. And it also offers a degree of transparency or interpretability. You can actually see the steps the model took to reach its conclusion, which can be invaluable for understanding its reasoning and identifying any potential flaws in its logic. Plus, it often leads to more consistent and reliable performance on challenging tasks.
Are there any downsides?
The main downside is that because the model is generating all these intermediate steps, the responses tend to be longer. This means more output tokens.
Which means higher costs and maybe longer waits.
Exactly. Higher costs and potentially longer processing times for you.
Can you illustrate with an example where chain of thought makes a significant difference, maybe one of those tricky logic puzzles?
Absolutely. LLMs can sometimes struggle with seemingly straightforward logical puzzles, especially arithmetic ones involving multiple steps.
Hmm.
For example, consider the classic question. Roger has 5 tennis balls. He buys 2 more cans of tennis balls. Each can has 3 tennis balls. How many tennis balls does Roger have now?
Okay. Seems simple, but maybe tricky for an AI.
Sometimes. A direct, non-code prompt might lead the model to make a simple addition error, maybe just adding 5 plus 2 equals 7.
Hmm.
However, if you employ chain of thought by adding a simple phrase like, let's think step by step to the end of the prompt,
And what happens?
the model is guided to break down the problem.
Hmm.
Okay, Roger starts with 5 balls. He buys 2 cans. Each can has 3 balls. So the total number of new balls is 2 cans, 3 ball scan equals 6 balls. Therefore, Roger now has his original 5 balls plus the 6 new balls, which is 5 plus 6 equals 11 tennis balls.
Ah, it shows the multiplication first.
Right. By explicitly prompting for the step-by-step reasoning, you guide the model through the necessary logical steps to arrive at the correct answer much more reliably. You can even combine COT with few-shot prompting by providing an example of a similar problem solved step by step before presenting the new problem.
So you can show it how to think step by step.
Exactly. And COT is also highly valuable in applications like code generation, where you can ask the model to first outline the logical steps involved in the code before writing the actual lines, or even in generating synthetic data by guiding the model through the specific assumptions and criteria it should consider at each stage.
That clearly demonstrates the power of prompting the AI to reason its way through a problem. Now, building on that, I encountered mentions of self-consistency and tree of thoughts in the research. These sound like even more advanced reasoning techniques.
They are indeed. Self-consistency builds upon the foundation of chain of thought. The core idea here is to generate multiple different reasoning paths for the same initial prompt.
Multiple COT answers.
Exactly. And then selecting the most consistent or frequently occurring final answer across those different paths.
How do you get different paths?
To implement this, you would typically run the same COT-enhanced prompt multiple times, often with a slightly higher temperature setting.
Ah, more randomness to explore different ways.
Right, to encourage the generation of more diverse reasoning sequences. After generating these multiple responses, you would then programmatically extract the final answer from each one and choose the answer that appears most frequently, basically. Take a majority vote.
Okay. What's the benefit of that extra work?
This approach can significantly enhance the accuracy and reliability of the model's responses, particularly for tasks where there might be multiple valid ways to arrive at the correct solution, or where a single cut path might occasionally go wrong. It also provides a kind of implicit confidence score in the chosen answer, as it's the one the model converged to most often across different reasoning attempts.
Seems more robust. Downside?
The main downside is cost and time. It's more computationally intensive because you're generating and processing multiple, potentially long responses for each single prompt.
Makes sense. Can you give an example?
Sure. Imagine classifying emails as important or not important based on complex criteria. You run a COT prompt with self-consistency, say 5 times with higher temp. Maybe 3 paths conclude important for slightly different reasons, and 2 conclude not important. Self-consistency would choose important as the final answer because it was the majority outcome.
Got it. Majority rules across different reasoning chains. What about tree of thoughts? TT, that sounds even more complex.
Tree of thoughts represents a further generalization of chain of thought. Instead of exploring just a single linear sequence of reasoning steps or even multiple independent linear sequences like in self-consistency, 2T allows the LLM to explore multiple different reasoning paths simultaneously and potentially branch off them.
Branching paths, like a mind map.
Kind of, yeah. It essentially maintains a tree of potential thoughts or intermediate steps, where each thought represents a coherent piece of language that contributes towards solving the overall problem. The model can then evaluate different avenues of reasoning by exploring various branches within this tree, maybe even backtracking if a path looks unpromising. This approach is particularly well suited for highly complex tasks that might require significant exploration, planning, look ahead, and consideration of multiple possibilities before a viable solution can be found. Think complex planning or creative problem solving.
These advanced techniques are really pushing the boundaries of what LLMs can achieve in terms of reasoning. Now, there was one more I wanted to ask about, REACT, which stands for Reason and Act. That sounds like it involves the AI taking actions beyond just generating text.
You're absolutely right. React is a sophisticated paradigm that empowers LLMs to tackle complex tasks by synergistically combining natural language reasoning with the ability to interact with external tools.
External tools, like what?
Think of it as the model being able to not only think through a problem using natural language,
Yeah.
the reason part,
Yeah.
but also to take concrete actions in the world, the act part. This could mean performing a targeted web search using an API to gather specific, up-to-date information, or using a code interpreter to execute a snippet of Python code and obtain results, or querying a database.
So it can actually do things.
Yes. This iterative thought-action observation loop closely mirrors how humans often approach complex problems. We reason about the problem, then we take actions to gather more context or test potential solutions, and then we observe the results of those actions to refine our approach and decide the next step.
Thinking, doing, learning.
Exactly. React has demonstrated impressive performance across a wide range of challenging domains, like question answering that requires current info, or tasks involving calculations. It's considered a significant step towards building more autonomous and capable AI agents.
So the AI can actually step outside of just generating text and interact with the external environment as part of its problem-solving process. That's a significant leap. Could you give us a practical example of how React might work?
Certainly. Imagine you want to answer a factual question that requires combining information, like how many children do the current members of the band Metallica have in total? And LLM's internal knowledge might be outdated or incomplete on this.
Right, band members change, have kids.
Exactly. Using React, the model might first think, I need to identify the current members of Metallica and find the number of children for each. Then, its first action might be to use a search tool. Search, current members of Metallica.
Okay, it uses search.
It gets the results, say, James Hetfield, Lars Ulrich, Kirk Hammett, Robert Trujillo. Then it thinks, okay, now I need the number of children for each member. So its next actions might be sequential searches, search James Hetfield number of children, search Lars Ulrich number of children, and so on.
Searching for each one.
Right, as it gets each result. For example, Hetfield, 3, Ulrich, 3, Hammett, 2, Trujillo, 2. It observes the information. Finally, it thinks, I have the counts for all members. Now I need to sum them. 3 plus 3 plus 2 plus 2 plus 2 is 10. Then it generates the final answer. The current members of Metallica have a total of 10 children.
Wow, that's impressive. Uses tools to gather the facts.
Precisely. Implementing React in practice often involves leveraging frameworks like LangChain or using platforms like Vertex AI that support agents. These provide tools to manage this thought action loop, define the available tools, and integrate with various external APIs and services. You also typically need to provide the model with clear instructions and maybe few-shot examples on how to effectively use these tools within the React framework.
This is really expanding the potential applications of LLMs way beyond just text generation. Now, before we move on to best practices, there was one more technique mentioned that sounds like it could be a real game changer for efficiency. Automatic prompt engineering, APE.
Yes, automatic prompt engineering, or APE, is exactly what it sounds like, trying to automate the often time-consuming and iterative process of crafting effective prompts by hand.
Letting the AI write the prompts.
Essentially, yes. The fundamental idea is to leverage a language model itself to generate a diverse set of candidate prompts for a specific task you have in mind.
How does that work?
You'd basically prompt a powerful LLM with a description of your task and ask it to generate many different ways to phrase a prompt for that task. For instance, generate 20 different prompts to ask an LLM to summarize a news article into 3 bullet points.
Okay, it generates prompt variations. Then what?
Then, you evaluate the performance of each of these generated prompts. This might involve running each prompt against your target LLM with some sample inputs and scoring the outputs using some kind of objective metric like Roja scores for summarization or accuracy for classification or even human evaluation.
So you test the generated prompts.
Right. Finally, you select the best performing prompt or prompts from the generated pool to use in your actual application. You can even take the most promising prompts, perhaps refine them slightly based on the evaluation, and feed them back into the process to generate even better variations.
Iterating on the AI-generated prompts.
Exactly. For example, if you're trying to get an LLM to help customers order a band t-shirt, APE might generate prompts like, order a band name t-shirt in size. I want to buy the band name T size, get me a size t-shirt for band name, and lots of others. You'd test which phrasing leads to the most reliable order processing by the LLM.
That's like getting the AI to help you figure out the best way to communicate with it. A meta-level optimization. Okay, this has been an incredibly thorough overview of various prompting techniques, from the simple to the really quite advanced. Now, let's pivot our focus slightly to how businesses can really harness this knowledge and apply these best practices in practical ways.
Absolutely. Mastering and applying effective prompt engineering can yield significant benefits for businesses across a really wide range of functions. It's not just a theoretical exercise.
Where are businesses seeing the biggest impact?
Well, for instance, in content creation, businesses can leverage prompts to generate compelling marketing copy, detailed product descriptions, draft emails, or even outline comprehensive blog posts, dramatically accelerating their content production cycles.
Speeding up marketing and comms.
Definitely. In customer service, well-crafted prompts can empower chatbots to handle a broader spectrum of customer inquiries with greater accuracy and efficiency, leading to improved customer satisfaction and, importantly, a reduced workload for human agents, freeing them up for more complex issues.
Better chatbots, happier customers, and agents.
Right. For data analysis, prompts can be strategically used to extract key insights and identify emerging trends from vast quantities of textual data, think customer reviews, survey responses, social media sentiment. This provides businesses with valuable market intelligence much faster than traditional methods.
Mining insights from text data.
Exactly. And as we touched upon with code prompting, LLMs can serve as powerful allies for developers, assisting in writing code, explaining complex existing code, translating between programming languages, debugging errors, and even reviewing code for potential issues or improvements. This can potentially boost development speed and enhance overall code quality.
A coder's assistant. Let's actually dig into that code prompting aspect a bit more. How exactly can LLMs help developers day to day?
Okay, yeah. Code prompting is a huge area. Firstly, you can use prompts to write code. Models like Gemini are trained on vast amounts of code and can generate code snippets or even entire functions in various languages: Python, JavaScript, Bash, SQL, you name it.
So you just ask it to write a script.
Pretty much, but you need to be specific. For example, you could prompt, write a Bash script that takes a folder name as an argument. Inside that folder, it should find all files ending with .txt and rename them by appending the word draft to their original name.
Okay, a specific file renaming task.
And the model would likely generate a functional Bash script to do just that. Of course, and this is crucial, you always need to carefully read, understand, and test any code generated by an LLM before running it, especially in a production environment.
Don't just blindly trust the AI code.
Absolutely not, but can be a fantastic starting point or handle repetitive coding tasks very quickly. You'd save the generated script, make it executable, and test it on a sample folder.
Okay, writing code. What about understanding existing code? That can be tough sometimes.
Totally. LLMs are often excellent at explaining code. You can take a piece of code, maybe one you inherited or something complex you found online, remove any comments, and prompt the LLM. Explain what this Bash script does step by step.
Using the script from before as an example.
Exactly. If you fed it that renaming script without comments, it would likely provide a detailed explanation like, this script first checks if a folder name was provided. Then it loops through all files ending in .txt within that folder. For each file, it constructs a new file name by adding draft to the beginning, and then renames the original file to the new name.
That's super helpful for documentation or just getting up to speed.
Immensely helpful. Another powerful use case is translating code between languages. Let's say you have that working Bash script, but your project standard is Python.
Can it convert it?
Often, yes. You could prompt, translate the following Bash script into equivalent Python code, and provide the Bash script. The LLM would then attempt to generate a Python script that achieves the same file renaming functionality, likely using Python's Oz or pathlib modules. Again, testing is key.
Wow, cross-language conversion. Okay, one more code area. Debugging and review. Can it help find bugs?
Yes, this is another strong suit. LLMs can help debug code and suggest improvements. Imagine you have a Python script that's supposed to process files, but it keeps crashing. Maybe you even have the error message, the traceback.
Like a name error or something?
Exactly. Let's say you have a script that tries to convert file names to uppercase, but it mistakenly uses file name to uppercase, which is JavaScript syntax, not Python. You get a name error. You could paste the broken Python code and the traceback into the prompt and ask, debug this Python script and fix the error. Also, suggest any improvements to make the code more robust.
What would it do?
The LLM would likely identify the to uppercase error and correct it to Python's file name.upper. But beyond just fixing the bug, it might also proactively suggest improvements based on best practices.
Like what kind of improvements? It might suggest adding checks to ensure the input is actually a folder, handling file names with spaces correctly, maybe using f-strings for cleaner string formatting, adding error handling with try-except blocks in case of permission issues, or maybe checking file extensions more carefully. It acts like a helpful code reviewer.
That's incredibly powerful for developers writing, explaining, translating, debugging, and improving code. Okay, so we see the potential across many business areas. Let's synthesize some of the most critical best practices that businesses, or really anyone using these models seriously, should keep front of mind when implementing prompt engineering.
Right. So pulling together some key threads. One of the most fundamental and consistently effective best practices, as we've discussed, is to provide clear and relevant examples whenever possible, using one-shot or, more often, few-shot techniques.
Show, don't just tell. Exactly. It serves as an incredibly powerful teaching mechanism, explicitly demonstrating to the model the specific type of output you're looking for in terms of format, style, content. It acts as an unambiguous reference point, guiding the AI towards your desired outcome. It reduces guesswork for the model.
Makes sense. What else is crucial?
Another key principle is to design your prompts with simplicity and clarity in mind. Your prompt should be concise, easy to understand, and avoid overly complex language or unnecessary jargon. Break down complex tasks if needed.
Keep it simple.
If a prompt is difficult for you to read and interpret, it's highly likely that it will also be challenging for the model to process effectively. Aim to use clear action verbs that directly and unambiguously describe the task you want the model to perform. Verbs like summarize, classify, extract, translate, generate, rewrite.
Be direct with the instructions. You mentioned some examples earlier, like the New York travel prompt.
Right. Instead of a vague "tell me about New York," a better prompt is create a 3-day itinerary for a first-time visitor to New York City focused on major landmarks and museums.
Much clearer, much more specific action.
Simplicity and clarity sound straightforward, but they're probably easy to overlook when you're trying to get sophisticated. What other key areas should businesses focus on?
Businesses should also strive to be as specific as possible about the desired output. A vague or generic instruction, like we just said, is unlikely to provide the LM with sufficient direction. This often results in less accurate or relevant responses.
Specificity matters.
Definitely. Incorporate specific details into your prompts, names, constraints, formats, target audience perhaps by leveraging system or contextual prompting techniques to help the model focus precisely on what's important for your particular use case.
Can you give another example of specific versus generic?
Sure. Instead of write a blog post about remote work, which is very broad.
Yeah, could be anything. Be more specific. Write a 500-word blog post outlining 3 key challenges faced by managers leading fully remote teams, and suggest one practical solution for each challenge. Target audience is HR professionals. That gives the model much more concrete direction.
Got it. Now, you mentioned something interesting earlier about instructions versus constraints, focusing on the positive.
Yes, it's generally more effective to use positive instructions over negative constraints whenever feasible. Rather than telling the model what not to do, example, don't include technical jargon, try to concentrate on clearly articulating what you want it to achieve. Explain this concept in simple, non-technical terms suitable for a beginner.
Tell it what you do want, not what you don't want. Why is that better?
It often aligns more closely with how these models are trained and how humans respond to guidance. Positive instructions provide clear direction and often give the model more flexibility to generate a good response within the desired bounds. Negative constraints can sometimes be misinterpreted or overly restrictive.
So going back to the blog post example.
Instead of "don't make the tone too formal," you could say "write in a conversational and engaging tone." Focus on the desired positive attribute. Now, constraints still have their place, of course, especially for safety. Enforcing strict formats or avoiding specific undesirable outputs. But try prioritizing clear, positive instructions as your primary method of guidance.
That's a really useful framing. Okay, what about managing the length of the AI's responses in a business context where conciseness might be crucial or you have character limits?
Yeah, controlling the maximum token length is indeed vital, partly for managing computational costs, as we discussed, but also for ensuring that responses adhere to specific limitations, like character limits for social media posts, like a tweet, or display constraints within user interfaces.
How do you control it?
You can either set a maximum token limit directly in the model's configuration settings if the platform allows.
Your backend setting.
Right. Or you can explicitly request a specific length within your prompt itself. For example, summarize this article into a single sentence, or generate a tweet under 280 characters announcing our new product. The model will usually try its best to adhere to that request.
Okay. Now, for prompts that businesses might use repeatedly, maybe with different inputs each time.
That's where incorporating variables into your prompts can be a significant time saver and enhance efficiency. Instead of embedding specific pieces of information directly into the prompt every time, you can use placeholders or variables often denoted with curly braces, like city or product name.
Like a template.
Exactly. Then, your application code can easily replace these placeholders with the relevant data at runtime before sending the prompt to the LLM. For example, provide 3 interesting historical facts about Diddy. This makes your prompts far more reusable and adaptable.
Much better than hard coding specifics.
Way better, especially when integrating prompts into automated workflows or business applications.
So, creating reusable prompt templates is a key efficiency gain. Are there any other crucial best practices for businesses to consider as they get deeper into this?
Absolutely. Businesses should actively experiment with different input formats and writing styles. Don't assume your first phrasing is the best.
Try different ways of asking.
Yeah. Different language models, varying configuration settings like temperature or top E, and even subtle changes in how you structure your prompt, phrasing it as a direct question versus a declarative statement versus an explicit instruction, can sometimes lead to noticeable differences in the quality and relevance of the output.
Can you give an example?
Sure. Asking what were the main reasons for the Sega Dreamcast's failure might yield a slightly different answer than stating, list the primary factors contributing to the commercial failure of the Sega Dreamcast, or instructing, analyze the reasons behind the Sega Dreamcast's market failure. It's worthwhile to try out different approaches and see what yields the best results for your specific business needs and the particular model you're using.
So, iterate on the phrasing itself.
Definitely. Another specific tip. If you're employing few-shot prompting for classification tasks, it's generally good practice to mix up the order of the classes in your examples.
Don't put all the positive examples first.
Exactly. If you put all positives, then all negatives, then all neutrals, the model might inadvertently learn a bias based on the position or order rather than the actual content. Mixing them up helps prevent this overfitting to the example sequence and encourages it to learn the underlying distinguishing features of each class more robustly. Maybe start with at least 6 examples, 2 of each class, in a mixed order for a 3-class problem.
Good tip for classification. And of course, things change fast in AI.
Absolutely critical. Staying informed about updates to the underlying language models is paramount. These models are continually evolving, with new versions and enhanced capabilities being released regularly.
Gotta keep up.
Make it a point to periodically test your key, validated prompts with newer model versions. You might find significant performance improvements, better adherence to instructions, or even new features you can leverage. Platforms like Vertex AI Studio provide valuable tools for tracking prompt versions, saving them, and comparing their performance across various models and versions side by side.
So, continuous testing and adaptation is necessary. What about the format of the AI's output? Should businesses think strategically about how they want the information delivered, not just the content?
Yes, absolutely. Experimenting with different output formats can be highly advantageous, particularly for tasks that aren't purely creative things like data extraction, categorization, structured information retrieval. Don't just accept a block of text if structure would be better.
Like asking for JSON.
Exactly. Consider explicitly requesting your output in well-defined structured formats like JSON or even XML, though JSON is often more common and easier to work with in modern applications.
What are the advantages of forcing JSON output?
As we touched on earlier, JSON offers several compelling advantages for business applications. It ensures a consistent and predictable structure, making it easy to parse programmatically. It helps focus the output on the specific data fields you actually need, reducing extraneous or conversational fluff. This structure can also reduce the likelihood of hallucinated information because the model has to fit the answer into the defined fields. It can explicitly represent relationships between different pieces of data. It provides explicit data types, strings, numbers, booleans. And of course, structured data is much easier to integrate into databases, dashboards, or other downstream systems. It's often sortable and filterable.
So for many business tasks, structured output like JSON is way better than just plain text.
For many data-oriented tasks, definitely. But sometimes the model might mess up the JSON, especially if the output gets cut off due to token limits.
What can you do then? Broken JSON is useless.
There are actually libraries available, like JSON Repair in Python, They can often fix incomplete or slightly malformed JSON strings, making the output usable even if the model didn't perfectly finish it. It's a handy tool to have in your toolkit.
Good practical tip. And related to structure, what about providing structure in the input?
Yes, that's another powerful technique, working with schemas. You can use something like JSON schema to define the expected structure and data types of the input data you provide to the LLM within the prompt itself.
Give the model a blueprint of the input data.
Exactly. For example, if you're feeding it product information in a generated description, instead of just pasting raw text, you could provide the data structured according to a predefined JSON schema. You might include the schema definition in the prompt, then provide the JSON data conforming to that schema. This gives the model a very clear understanding of the fields available, like product name, features, target audience, price, and their types, helping it to focus on the relevant details and generate a more accurate and tailored output.
Structured input helps get structured or better output. Okay, shifting gears slightly. What about the process of prompt engineering itself within a business team? Any best practices there?
Collaboration and knowledge sharing are key. Encourage your team to experiment together with prompt engineering. Don't just have one person doing it in isolation.
Why is collaboration important?
Different individuals often bring unique perspectives, different ways of thinking about a problem, and creative approaches to phrasing prompts. By sharing their findings, comparing results on standard test cases, and giving each other feedback, teams can often collectively arrive at more effective, robust, and reliable prompts much faster than someone working alone.
Get diverse eyes on the prompts. Makes sense. Any specific tips for those advanced techniques, like chain of thought?
Yes, for Kohei best practices. It's generally recommended to structure your prompt so the model puts the final answer after it has articulated its reasoning steps. Make sure you design the output format so you can easily identify and extract the final answer programmatically, separate from the preceding chain of thought. And, as we mentioned, for copy prompts where you want logical deduction, it's often advisable to set the temperature to a lower value, closer to 0, as you're typically aiming for a deterministic reasoning process, not creative variations.
Okay, practical cookie tips. Now, you mentioned documentation earlier, but it sounds like it deserves re-emphasizing for businesses.
Absolutely. This is perhaps one of the most crucial, yet sometimes overlooked, best practices for businesses aiming to leverage prompt engineering effectively and sustainably. Meticulously document all of your prompt engineering efforts.
Which should be documented.
Maintain a detailed record. This could be a shared spreadsheet, a database, or notes within a platform like Vertex AI Studio. You should track, for each significant prompt iteration, the prompt version number or identifier, its intended purpose or the task it solves, the specific language model and version used, the exact configuration settings, temperature, top K, top P, max tokens, the complete prompt text itself, ideally some examples of the outputs generated, whether those outputs were deemed successful, okay, or not okay, based on your predefined criteria, and any feedback, observations, or ideas for the next iteration.
That sounds comprehensive.
It needs to be. If you're using a platform, save a direct link to the saved prompt for easy access and reproducibility. This comprehensive documentation is invaluable for learning and iterating over time, for revisiting previous work without reinventing the wheel, for systematically testing performance across different model versions, and for effectively troubleshooting any issues that may arise when prompts suddenly stop working as expected, perhaps due to a model update.
What about systems using retrieval augmented generation, RAG?
Good point. If you're working with RG systems, where the prompt includes content retrieved from a knowledge base, your documentation should also capture the key parameters and strategies employed in the retrieval process, things like the embedding model used, the chunking strategy, the similarity threshold, the number of retrieved documents included in the context. Because these factors significantly impact the content being fed into your prompt, they are part of the overall prompt engineering process.
So document the retrieval part too. And how should prompts be managed in a real project?
As your prompts become more refined and critical to your business processes, treat them like code. Consider storing them in separate files within your project codebase, for example, .prompt files or similar, rather than hard-coding them directly in your application logic. This makes them easier to manage version control using Git, review, and update. And ideally, especially for critical applications, implement automated tests for your prompts. These tests would feed the prompt known inputs and assert that the output meets certain criteria or matches an expected structure, ensuring their continued performance and reliability over time as models or application logic changes.
Treat prompts like code version control, testing, documentation. That really elevates it. Document, document, document. It sounds like effective prompt engineering, much like robust software engineering, relies heavily on careful record keeping, collaboration, and iterative refinement. This has been an incredibly insightful and practical deep dive into the world of prompt engineering.
It has been a pleasure. And it's really crucial for you, the listener, to remember that prompt engineering is fundamentally an iterative and ongoing process. It's about experimentation and continuous learning.
Not a one and done thing.
Not at all. The more you actively practice and apply these techniques to the specific challenges you face in your work or your projects, the more skilled and effective you'll become at guiding these powerful language models to achieve your desired outcomes, whether for business or personal use.
Absolutely. And by grasping these core principles and best practices we've discussed today, you, our listener, now possess a significant shortcut, really, to effectively harnessing the immense power of large language models for your own professional endeavors and business needs.
So maybe here's a final thought for you to consider as you begin to apply these insights. How might the continuous evolution of prompt engineering getting better and better at talking to AI ultimately reshape the fundamental ways in which we interact with and extract value from artificial intelligence in the future? Could it perhaps become a core digital competency, something as essential in the modern workplace or even daily life as proficiency in using search engines effectively or crafting clear emails? Is prompt literacy the next frontier?
That's a truly thought-provoking question to ponder. Will interacting skillfully with AI become a basic literacy? We encourage you, our listener, to consider which of these prompting techniques and best practices could have the most significant impact on your current work or areas of interest, and to take the initiative to explore and experiment further. Thank you for joining us on this deep dive.